Thank you for coming to demo theater presentation about transformations. My name is Bojan Šaurić. I am a software developer for projection engine team. And here with me is Melita Kennedy. She's our senior product engineer. So let's get started. In general, what we have in our software are two kinds of transformations. We can have geographic or datum transformations, and we have vertical transformations. Now, geographic transformations are those who transform between two geographic coordinate systems. In most cases, goes for transformation between some local geographic coordinate system versus global coordinate system, or it goes just simply for transformation between old and the new geographic coordinate systems or datums. So in my slides and later as well in my demo, I'm going to use an example of Slovenia. Slovenia is a Middle European country that changed their datum in 2008 from D48 to D96. And that time, they also provide transformations, government provide transformations to go between the coordinate systems. So for a particular pair of geographic coordinate systems, you can have none, you can have only one, but in most cases, what do you have? You have multiple transformations. They are basically valid for different areas, different regions, or they can be valid for different states. And also what they have different accuracies. In general, when the transformation area is split on more regions, better is accuracy. So in our example, in Slovenia, when the country is split on 3 different regions, those transformations are less accurate than when the country is split on 7 different regions. So with so many different transformations that are out there, the question that is the most difficult is like, how do I find the transformation that I want to use? And short answer to that is, don't worry, we're going to kind of take care of that behind the scene. So when the user, for example, in Project Tool, selects the data they would like to transform and also selects the coordinate system they want to transform to, we generate so-called transformation list. So, and how do we do that? First step, what we do, we intersect the envelopes, starting with the envelope of your data, then envelope that represents area of use of your data's coordinate system, as well as your target coordinate system, and finally area of use all transformations that are available between 2 geographic coordinate systems. Now, transformation that basically have at least some sort of association with geographic coordinate system and with the data shows on the transformation list. The transformation that has the largest intersection basically shows up on the list first, followed by the rest of followed by other transformations. So in our slides here, the big envelope basically presents the area of use of the old Slovenian geographic coordinate system and the new one as well, because it's pretty much the same. At the same time, the big envelope presents also the countrywide transformation. The smaller ones are 2 envelopes that represent other transformations that are valid for this data. And if you look very carefully, you can see that all 3 transformations, when you intersect those envelopes, they're going to have complete coverage of the data. That means that we need a tiebreaker to kind of distinguish between the transformations. And for the tiebreaker, what we do, we use accuracies. So countrywide transformation has 1 meter accuracy, central transformation has 0.3 meter accuracy, and the southeast transformation has half meter accuracy. So on the transformation list, the central transformation is going to show up first because it's the most accurate and covers the whole data, followed by southeast transformation with half meter accuracy and countrywide transformation with 1 meter accuracy. After that, we're going to have other transformations that they have a smaller intersection with the data. So the information that basically we got about these transformations comes from EPHG registry or we usually also get information from the governmental agencies when we implement that into the software. So now let's move to the demo and see how this actually looks like. Okay. So here in Arc Pro, I have a topographic map of town called Litia. You can see structures, river, some contour lines. And if we go to take a look at the coordinate system of the data, let's see here, we can see that the coordinate system is actually old Slovenian coordinate system, D4A8. But my map here in this particular map is using the new coordinate system, so I will have to select the transformation at some point and verify if this transformation is the one that I want to use. So if we go to the full view and just explore what we have, here's the full view of the country, and with the red rectangle here, we have marked the location of the data. So all these envelopes here that I have on this right now open, they show area of views of different transformations. And as I mentioned before, the larger envelope presents the countrywide transformations as well as target and start coordinate system. And yeah, this transformation covers the data, therefore transformation is going to show up on the transformation list. We have 3 transformations that are having a half-meter accuracy. Here they are, their envelopes, and we already can see that only one transformation covers the data, which is Jugovzhodna or southeast transformation. Then there are 7 transformations that have 0.3 meter accuracy, and out of those, central or Osrednja transformation completely covers the data, as well as lower Krnjola or Dolenjska transformation also covers completely the data. There's also one more transformation that partially intersects with the data called upper Krnjola or Gorenjska transformation. So if I zoom in here, you can see that like the transformation just barely touches it, but because it at least partially covers the data, it should be basically showing up on the transformation list, but it's going to show up after the rest of the transformations. So if we go now back to the data and we take a look at the transformation list we have in the system, we're going to see exactly what I was basically showing. First, we have central or Srednja transformation and Dolenjska transformation. They completely cover our data set and they have the best accuracy. Followed by southeast transformation, which have meter accuracy, and then there are 3 versions of whole country transformations. After that, we have Gorenjska or upper Krnjola transformation, even though it has 0.3 meter accuracy, it shows up after the rest of the transformations because it does not completely cover the data set. Okay, so this is the way how it basically works. So now let's take a look some common problem that usually users have. So here I have on my map the data of basically of roads in Cambodia and Vietnam. And if you take a look at the geographic coordinate system for this data set, we can see the data set is stored in Kalyanpur 1975 geographic coordinate system. But what I want to do is I'm going to create a web map. So I want to use this data and I want to pre-project it basically to web Mercator projection so that I can basically simplify my work. So I set up project tool, I specified all information, but for some reason the transformation doesn't show up. But I know that there is a transformation between the WGCD4 and Kalyanpur dataset, 1975 geographic coordinate system. Simply, it is not clear why the transformation is not on the list. We know that transformation completely covers the world because it is a worldwide transformation. So this should not be a problem. But if you look more into detail, you can see, you will find out that the area of use for Kalyanpur 1975 geographic coordinate system is basically cover India. And my data set is completely outside of that domain. Therefore, the transformation doesn't show up because the data is in the incorrect geographic coordinate system. So instead of using the data of Vietnam, and if I use, for example, roads of India, which are well within the area of use of the coordinate system, I should not have any issues. So instead of selecting Cambodia and Vietnam roads, I select Indian roads. As soon as I do that, my transformation shows up on the transformation list, and I can correctly use transformation. Okay, so I think that's it, and I'm going to give it. It can be wrong coordinate system. In that particular case that I have here, it is the right coordinate system. But because the data in between was clipped, it kind of flipped, kind of switched outside of the domain of the geographic coordinate system. So the whole workflow is usually I have a world data set, I make the map of India. So I want to make everything to be synchronized. So I move everything to Kalyanpur data set, but then I try to reuse the data for some other purpose, and I want to simplify that, and I just clip the data to those two countries. The whole thing was done correctly, but in the process, you kind of move the data outside of the domain. And the thing is that Kalyanpur roads, when they were transformed from WGS84 to Kalyanpur, they were correct for the India because there was the target coordinate system and transformation was there. But whatever data you have outside, that not necessarily is going to be on the correct location because your transformation in the process was designed for that small area. So also going back, you don't have any insurance that you're going to do the right thing as long as you don't have all the data. So, okay. So let's switch to Melita, and she's going to talk about other transformations, vertical transformations.
Okay, so everyone can hear me in the back? Good. So vertical transformations were new to ArcGIS Desktop and Server 10.4.1 and for Pro 1.4. So when we started putting in vertical transformations, one common method is you're going to go from ellipsoidal heights, in this case NAD 1983, to orthometric heights in NEVD88. These are both US-based systems. And when we put together the transformation names, we try and give some information in the name, and you can use that to help you guide you on what's happening. So in this case, we've got this very long mouthful of a transformation name of NAD 1983 to NEVD88, CONUS geoid 12B height. So right there, I've got my from and to vertical coordinate systems. CONUS is telling me it's for the contiguous US, the lower 48 states. Geoid 12B is telling me the model I'm using. That's a particular geoid model. And then I'm working with heights. So in the tools, project tool, if you want to convert your Z values, you have to opt in. So there's actually an option where you have to checkbox the vertical option in order to get your Z values to convert. Otherwise, it's going to treat the data as if it's 2D, even if the data really has a 3D dimension to it. So vertical coordinate systems basically tell you where the origin is for your Z values, heights or depths. And there's two main types, so which I already mentioned. There's ellipsoidal heights, i.e. the reference to the actual ellipsoid surface, to the horizontal datum's ellipsoid surface. That's very common. That's what you get natively from GNSS, GPS systems. Natively, you get ellipsoidal heights. The other one is a gravity-related height, so like a tidal datum where you care like mean sea level or low water, or like a national, the national vertical coordinate system for a country is usually gravity-related, based on a geoid model, based on some sort of gravity-related system. So we got a couple different types of vertical coordinate systems, vertical transformations. The one I already showed was the between ellipsoidal and gravity-related heights. So in this case, we start at the blue box in the lower left corner. We're going to go from GCSA and BCSA, that's ellipsoidal, to GCSA, BCS2, where I'm switching from ellipsoidal to gravity-related. And that could be done using, for instance, a geoid model, which models that offset between those two surfaces. Another case is where we're going to convert between two geographic coordinate systems and include ellipsoidal heights on them. So for instance, we might go from GCSA, BCSA over to GCSB, VCSB. We're still in ellipsoidal heights, and we're going to run that as a 3D geographic transformation. The last type is between two different gravity-related height systems. So in this case, again, starting at the lower left in the blue box, we've got GCSA, VCS1. We're going to stay on GCSA and only convert our Z values to VCS2. One thing that may happen is that a lot of the transformations for vertical data in particular need some sort of file. We actually go out to a file on disk to figure out the offsets. And that might have a different interpolation that it needs to do, maybe uses a different GCS. So maybe we can't get there directly between the two gravity-related systems. Maybe we got to do something else. So in this case, I'm starting again with the blue box. I've got GCSA, VCS1, gravity-related system. I'm going to do a 2D geographic transformation over to GCSC, still on VCS1. Now I can do the vertical transformation. So I'm still on GCSC, but now I can do VCS2, now that I'm on the right interpolation GCS. And finally, I can get back to the beginning using another 2D geographic transformation. I'm still on VCS2, haven't done anything to the Z values, but now I'm back on GCSA finally. Okay, now I've got a short demo. Yep. My computer hates me. There we go. Yeah. All right, so I've got some data in Bowdoin County, Bowdoin Canyon. It's here in Southern California. And so right now I've got only one layer turned on. This is actually ellipsoidal heights on WGS84. So now I'm going to turn on another one that's also ellipsoidal heights, but it's ITREF 2008. So you can see there's not much difference. You can see there's a little bit of black showing up. That's actually an artifact, but overall the data is pretty well aligned. Now I'm going to turn on another one. This is WGS84, but now the vertical coordinate system is EGM 2008. That's a gravity-related system, and you can see now there's more of an offset between the two layers. I'm going to turn off ITREF 2008. So now you can see the blue and black systems are definitely a little bit farther off. So now if I open up my scene properties, currently we're actually in a completely different coordinate system. I'm on NAD 1983-2011 for my GCS, and my vertical coordinate system is actually ellipsoidal heights on NAD 1983-2011. If I switch down to the transformations section, here are all the transformations set for these. So currently it's already got the transformation set for getting from WGS84 to 2011. So I'm going to turn that off. I'm going to turn off EGM 2008. But you can see, just like we saw with Boyan's demonstration, you get a whole list of transformations here. We're sorting that by extents. We're sorting that by the accuracies of the transformations. Right, so now you can see the offset. Now I want to switch over to show some of the gravity-related systems in the US. This is a NAD 83, NEVD 88. And I'm going to turn on another one, which is also NAD 83, but now the vertical coordinate system is NGVD 29. This is the older gravity-related system in the US. And you can see they're off a little bit, but they're very, very close. I know, they're all set. Yeah. So what I want to do is I'm going to turn off these so you can see the offsets. So now if I turn on the NGVD29 one again, you can see how far off it is. This is actually because NGVD29 is in feet. So that's why we're seeing such much offset. If it was in meters, it would be showing within a meter or so of the NVD88 data. So I'm going to also turn on the NAD27 NGVD29 data, and you can see it's also very far offset up, and then also kind of left and right. So that's where we're seeing both the horizontal datum is offset in NAD27 versus NAD83, and then also the verticals are offset. So now if I go in and I start setting these, and you'll notice in here that if you see a tilde in front of the name of the transformation, it means we're applying it in the opposite direction. But all these transformations, both for horizontal and vertical, are bidirectional. They'll go in either direction and we'll handle it for you. You don't need to worry about it. So a transformation, when we define it, has a particular native direction for it. So like, for instance, this one right here, we go from NAD83 2011 to NEVD88. That's the native way direction is applied for it. But in this case, we want to go the other direction. We've actually got data in NEVD88. We want to put it back to NAD83 2011 ellipsoidal heights. So we're going to apply the transformation in the opposite direction. The tilde is just a visual to show you this transformation is defined this way, but we're going to apply it the other way. Yeah. So the question was, okay, let's say we have a transformation and the error is 0.3 meters, and we apply it in the forward direction. And then let's say we want to take the data, and now we're going to go we're going to go back basically. So what we call it a round trip. We're going to round trip the data. Does that apply again? So do we possibly lose 0.3 forward and then 0.3 back so we get 0.6? No. Basically all of our transformations are designed so that they round trip, I want to say losslessly, i.e. you're not going to see shifting, but you will see shifting way down in the end, but not at a level that it matters for the data. So right now you'll see some of these have very big lists. Right now we have a restriction on a length of a transformation path, i.e. we can chain together transformations, but right now the limit for vertical plus horizontal are 4, 2 of which can be geographic and 2 of which can be vertical. And that covers most of the cases we've been seeing so far. So you can see we managed to get the one layer down, but we still have the NAD27 NGVD29 layer stuck up in the air. And if I go back and look at the properties again, you can see we're getting a warning. But however of that, basically it says I can't find a path. I can't find a transformation. And part of that reason is because we're hitting that 4-step limit. NAD27 is far enough back in time that we can't get all the way up to NAD83 2011. There's like 4 steps in between to get to there from here. We can't just quite do it. Right. So one other thing that happened when we started putting in the vertical transformations is some of their files are really, really big. The EGM 2008 data, which is the worldwide GEOID model, is just under a gigabyte of data for the really accurate version of it. And we could not put that in the core installs. It's just too big. So starting again with 10.4.1 for desktop server and 1.4 for Pro, we made a separate setup called ArcGIS Coordinate Systems data. Originally, there was one for Pro and one for desktop server. We've managed to combine that if you install Pro per machine, i.e. for everybody. If your organization installs Pro per user, there's a particular per user install you have to install because it all gets put in your user profile area. So if you have control, or you know who does have control for installs, you can tell them to go to My Esri, go to My Organization and Downloads, and then either search or look under Data and Content and just search Coordinate Systems. These are tied to a release, but for instance, you might install this for Desktop 10.7, for instance, and you've got Pro 2.3 installed as well. And then Pro 2.4 comes along. If we haven't added any data to this setup, you can keep using the same setup for the data side. Right now, it's about just over 1.5 GB of data on the and any new data coming in. Geographic transformations, vertical transformations are all going into this setup. Nothing's going into the core setup anymore. So for the geographic transformations, we've got files for the US for GeoCon version 1, NTV2 files for Australia, Belgium, Canada, Spain, Switzerland, and UK. On the vertical transformation side, we've got data for the US for GEOID 12B, again, GEOID model, and from VertCon, which gets from NVD 29 to NVD 88. We've had GEOID models for Japan, New Zealand, and Switzerland. And then finally, we've got the World EGM 2008, which is the current worldwide one. There's another related session on Friday morning introducing coordinate systems and transformations. If you're interested in going to that, it's at 10 a.m. in San Jacinto room. We did not do the ordering of these two sessions. Please take the survey. We really do look at any comments you make. We were planning to kind of redo these again for user conference this year. So any comments you have on these or the one on Friday, we will gratefully appreciate getting any comments. So, that's it. Thank you very much.
Thank you.